a minute ago, or last period, we basically made a percent solution. Show you how to make a percent solution. Let me show you why we don't use percent solutions very often in chem. Watch. Okay. You might think to yourself, here I have some sugar, 5 grams, and some salt, 5 grams, and I'll put in, it's like 25 grams of water. Now, if I were to add this 5 grams of salt to that 25 grams of water like I did in the first problem, it would be the same percent solution as adding this 5 grams of sugar. But they would not be equivalent by any means. And I want you to see why. Can anybody see why that could be the case looking at the formulas for salt and sugar?
One's a lot bigger.
Yeah, one's a lot bigger. So basically 5 grams of this stuff, the sugar being C12H22O11 and weighing something like 300 and some grams per mole, is nowhere near as heavy as the salt, which we found in the other, I think it's like 58.443 grams per mole. So basically, 5 grams of this sugar isn't as much sugar as 5 grams.
Sorry for the
It's okay.
2 seconds. I just wanted to get this material
Oh, yeah.
out tomorrow. So I want you to have a heads up. I just
Yeah, I'll
need
look
10
out for
copies
it.
of each.
Okay.
So this is for the 8th
Oh,
grade.
10 copies, good.
Of each.
Okay.
And then I have these, and I'll go over this part, but I just want you to have it in case I didn't see it.
No problem.
Okay.
Thank you.
Yep.
All right. So take a look. These are not the same. They're not the same, and I can't very well say that they are, even though the percentages are the same. They're exactly going to be like if this were 5 grams and 25. What do we figure the 17%? We said we 35 over 30, right? So they both be a 17% solution, but they're not equivalent. All right, and that's why we're going to have to do something called, turn the light off, molarity.
Oh God, we're doing notes.
Okay. Something called molarity. Molarity, as the name implies, is probably going to have what in it?
Moles.
Moles, absolutely. And once again, as I told you to get used to for these next couple of days, several days actually, I'm not going to be giving you a lot of notes. We're going to be doing problems, so the end of the notes are going to be right after I give you the formula. The formula for molarity looks like this. Instead of taking just the mass of the solute over the mass of the solution, you're going to take the moles of the solute over the liters of the solution. That's a big difference because moles are a much better way of measuring how much stuff you have than just the mass of it, because different things, weigh different amounts. Okay?
Is it a percent?
No, it's not times 100. It's just moles over liters. Got it?
All right.
All right. Which also makes it a little bit easier to do the calculation too. So let's do several problems for this one. Ready? Calculate the molarity of a solution if 5 grams of salt is dissolved in 100 milliliters of water solution. By the way, I have to show you one other thing here as a demo before we get to the actual lab, kind of hinting ahead at the lab for Friday about what you actually have to do and mixing these together. We'll see that after we do the problem though first. Let's do the problem first. Copy that question down. And let's write the equation for molarity. Molarity is, by the way, abbreviated with a capital M. Capital M, not a low M. Lower M. Molarity is going to be moles of solute over liters of solution. Okay? Now, do I know how many moles of solute I have? Does it say how many moles anywhere? No. It says I have 5 grams of salt. What do you suggest I do with that? I can convert grams to moles. So it's going to be 5.0 grams. Grams in the bottom, moles in the top. 1 mole contains, like I said, it's about 58.443 for the mass of. Well, how did I get that? Where did I get 58.443? What did I do to get that molar mass of this guy? I added sodium and chlorine together. Okay? Now that's the numerator. What's the denominator? What am I going to divide it by? 100? 0.1. Why? Because it's 100 milliliters. So be careful of that. Milliliters, you should know how to convert milliliters to liters by now. You want to do it the old-fashioned way, milliliters to bottle, liters on top, you can. But by now, we've done it so many times, I think you realize it's off by 3 decimals, 3.100 liters. Now, get your calculator out, do the math for that. What do you get for your molarity? What did you get? 0.86? Because, is that right? Because we have 2 significant figures here, so you should have 2 significant figures in the answer. Now I want you to write this down here, watch. 0.86, capital M is one way to write it. Now how do I read that? Well, that is read, write this underneath it, 0.86 molar. That's actually what you say, molar. It sounds weird to say 0.86 molar as your answer. Usually it's molar than what? You know, like bigger than what? Molar than what? It's molar. That's just how you say it. All right. And finally, another way you could think of it as 0.86 moles per liter. All of these are the same thing. 0.86, we're going to learn in Chem 2 actually that if I put it in brackets, it also means concentration in moles per liter or molar. So there's a lot of ways we write molarity. Capital M, molar, moles per liter, or even brackets around that, which in Chem 2 we'll talk about. But right now, let me show you, before I go to the next examples, let me show you this. There's a problem when you get to the lab tomorrow, or Friday, I mean, not tomorrow. Can I just take, here's my, can I just take 100 milliliters of water, fill this up to 100 milliliters of water, right, and add my 5 grams of salt to it? Does that make it this concentration? What's wrong with that? What's wrong with this picture? Okay, what's wrong with this? What's the problem with that? What happens to the level of the water when I do that? 5 grams added to 100 milliliters of water, what? What does it say? Solution. It didn't say water. It said water solution. So that has to be 100 milliliters, not before I add it. Because when I add this, won't that make the water go up a little bit? That's why to make a molar solution, you actually technically should do this. If you use this, it's called a volumetric flask. And it's exactly 100 milliliters right to that line. There's a line right here, if you can see it. Okay, so right to that line is 100 milliliters. Can y'all see that? Emily? Emily?
I can see it.
All right, so what do you suggest I do to make that solution above? What would I have to do? Yes, I'd have to put the solute in first. I'd have to take this. I'll use a funnel so I don't spill it like I did last period. I'd add my solute in first, my 5 grams of salt, and then I would pour my water in and fill it up to what point? Right up to that thing. Right up to that bottom of that line, or right, not that line actually. Bottom of the meniscus on the line. And if I had a little squirter, it would be easier. Let's just say it was perfectly on there. Let's mix it up, and that would be a 1 molar solution. So the difference is, if I were to have added that salt to it once it's at 100 milliliters of water, it would make it go up by more. All right, so that's another little change, a little different. Now, granted, I got to be honest with you. When I make up a molar solution, the change in the volume is not very large, and so I generally don't care when I'm making it up. For you, if I make a 1 molar solution, if it's 1.2 molar, or 1.02 molar, or something like that, it's not going to matter very much to me, or 0.1 or 0.98 molar. Okay, so most of the time I don't really care about that, but that's the way you would do it to do it right. You'd have to add the salt in first and fill it up to the 100 milliliter mark with water. Okay, all right, let's do some of these backwards in different directions, different ways. Try this guy. How many moles of solute are in 2 liters of a 4 molar solution? Now, I purposely made this guy to get across to you how not everything is about chemistry. not all these problems are even about chemistry. A lot of them are about common sense. And if you understand it, you know the answer to this question already. You don't need a calculator. You don't need to use a formula. It's that simple. If you don't understand, I'm going to use an analogy that will hopefully make it understandable to you. What is the answer? How many moles of solute are in 2 liters of a 4 molar solution?
2.
Not 2. 8. And here's why. Watch. Use this as an analogy. I've used this before, if you remember. I call this a baskets and strawberries kind of problem. I hope you went picking strawberries at Seychelles last year because they're closed. They're going out of business from what I heard. I know. I feel bad about that. I probably put them out of business for all the strawberries that I was eating when I was picking, and my kids ate when they were picking. You ever go picking strawberries there?
Yeah.
Okay. Well, let's say you went picking and you brought 2 baskets with you. Now, you have to weigh the baskets, but whatever. Let's just say each basket held 4 pounds of strawberries. You fill both baskets up. Tough question now. How many pounds of strawberries did you pick? 2 baskets, each one held 4 pounds. How many strawberries did you pick? 72 pounds. Now, how many pounds? 8. Okay. That's the same problem. It's the exact same problem as up here. Take a look. Say, well, how can it be the same problem? Well, it's the same problem for the reason I just gave you as the analogy, the common sense approach. It also works if you remember what I taught you back the first time I gave you any calculation, which was conversions. 4 molar, and I just mentioned this a minute ago, 4 molar means 4 moles per liter. They're the same thing, right? 4 moles is 4 moles per liter. 4 pounds of strawberries in every 1 basket. How many baskets did we pick? How many fill up, 2 liters. I told you it works both ways. As a conversion, notice the liters cancel, right? What's 4 times 2? 8 moles. Exactly what it was asking me for. Got it? 72. Exactly. Just confusing people at home now. All right. Luckily, there's nobody at home. All right. 4 moles contain, or 4 moles per liter times 2 liters. By conversions or by common sense, that's all you got to do. Now, let's do the next example.
Why are you videotaping this?
No particular reason.
No, if there's no one absent.
There's no one absent in this class. There's no one absent this year. Doesn't mean there won't be anybody absent when I put it up next year. And everyone's asking, who the heck was that stupid Emily girl? I kept asking all those dumb questions.
Still no, they won't even ask.
Yeah, but what about 5 years from now? Then what?
Still
So leave
floating
it
around.
like
Everybody
it's
teaching for that long?
Probably.
How long do you have left?
I'm sorry.
5, 6, 10. Who knows?
72.
72 years.
You
72
know my
years.
sister?
I had all the Delos.
No, get out before this year.
She's in 7th grade.
Get out.
Not that Delo. Not the other ones before you.
No, but she's in. Will you be here in 7th and 7th grade?
Yeah, sure. That's only like 3 years away.
Leave before then.
Yeah. go to
And
a
she's
different
smart.
school.
So she might be Emily then. Be here next.
Or even 2 years away. Okay. Now, I purposely put this one up here to show you that as soon as I change one little thing, you automatically don't know how to do it. This problem is virtually identical to the problem above it. It doesn't look it, but it is. There's one word difference. How many grams versus how many moles? Okay? If I wanted grams of this guy up above, what would I have to do? One more step, right? I would have had to convert moles to grams, correct? Let's do this guy the same basic way. 0.240 molar solution is 0.240 moles per liter, correct? That's my starting point. That's what I know. I have 0.240 moles in every 1 liter. How many liters do I have? 0.500 liters. Liters cancel. Now don't hit equals. Don't get your calculator. Another nice part about doing these as conversions is that I can keep going with these. Do I have what I want at this point? No, the question asked me for grams. So I now have gotten rid of liters. I'm in moles. What will I do? Moles in the bottom, grams in the top. 1 mole contains the mass of oxygen, which we all know is what? 15.999, right?
No.
No. Because now it is oxygen gas. Oxygen is diatomic, and it would be 31.998. And you multiply it by 2. Notice that's one of those more masses you kind of already know off the top of your head because you've seen it so many times.
No, it's not.
Except for Emily.
I was really wondering if I would.
All right, do the math for that. What do you get?
72.
72. Again, 72 is bacon, or 72 is the answer to everything.
Yes.
Like the
Or 42.
No, wait.
Or K.
Yeah,
It's
yeah,
42.
42 is,
42
is the answer to life, the universe, and everything.
Okay. Is that
It's always been that way.
okay?
Even he looked at that and he was like,
Right.
Well, I think that's from the Hitchhiker's Guide to the Galaxy.
Yeah.
I've read it, but I'm just saying. That's why I get it. But nobody else in here has, just so you know.
Exactly has.
Anyway, what's the name? What's the answer? Besides 42, 72, or bacon, what's the answer?
3.84.
3.84. Everybody else get that?
Sure.
Did we all get that? All right, that's how many grams there are. Also known as bacon.
Yes.
Okay. All right.
Got a rip.
Now, do I have any more examples? I don't think I do. Oh, homework's up right there. That's the homework.
No.
No.
Wait, wow.
My whole